Okay, guys, now you may ask your question. All right, sorry. Yes,
Yeah,
what is
I
your
couldn't
question?
do the demo version. The demo version
Yes.
wasn't open for me.
The so, Mister, I was the first to ask the question.
Yes,
As
Murat.
I understood, the exam will be on our free time, not on our lesson time, not right now. The exam will
Yes.
be any our free time until the deadline, which is tomorrow, 12 p.m. Am I correct?
Murat, about this exam, last time I told you, I have nothing
I
to
was
do with
apply.
this exam, all right? I have nothing to do. I'm
I
not
was.
the one who is a part of this organizer. We should ask this kind of
I
questions to
wasn't.
Miss Aisu or Mr.
Mister.
Adalat.
Okay, Mister,
Uh,
can you just say, will we do exam now in the lesson?
No, of course, this is the lesson. Here
Okay,
we have
sure.
math class here. This no exam. It's not my exam.
Okay.
Mr. Kazam.
Okay, that is the exam that is organized by I think this Sasmo committee or organizers. Okay, this by Mr. Adalat. It is not here. Here we have scheduled class. It's just a class time, and sometimes I may want to see your progress by asking you some questions, right? But that test is very different. It's like kind of what is it? We call this maybe mock examination. It looks like a real exam, but it's not real. And to prepare you for the real exam, because as you see here now, you're asking. I mean, I see some master's students are asking, how should I put my name and surname and my email? How do I sign in? Blah blah blah. And why usually actually this kind of organization or whoever organizing this contest, they actually organize this kind of exam to prepare students for the real exam, so that on the real exam day you will not experience this kind of unexpected problems or technical problems. So now if you just sign in, right, you know how to do the questions, where to put the
yeah.
questions. So you will be ready for the exam in April, so that you will not have to ask any question like this. Okay.
Mr.
Okay, and what does this exam decide right now?
Yeah, and this, again, I think so you didn't get me. This exam to introduce you with this contest, okay? Now, Murad, you should not actually look at the exam only from your point of view. There are a lot of students from different schools, and they are not taking this class from me, right? Because here, maybe I'm explaining and Sasmo type questions. Now you have some idea, right? How many questions, what types of questions, how many minutes is given, how you should try. But a lot of students, they have no idea even what kind of questions they are going to have. So that's why now they have to introduce, right, this contest to the students. Do you understand this? They should try some questions. Okay, what kind of questions they're going to have in this contest? Do you understand, Rifa?
Yes, I do.
Good.
Mr. Kazam.
Yes, I am.
So, since I was absent on Wednesday, could you please briefly retell me everything that you discussed about the
I was
exam?
also absent on Wednesday.
I say again. Could I do what?
Since I was absent on Wednesday, could you please briefly retell me everything that you discussed about the exam? Because I had no idea about it until the other students texted in the chat.
Hmm. Now, actually, about the exam, Miss Ayan, about the exam, you should not ask me about the exam. You should ask Miss Aisu. You know, here we have Aisu. She is the secretary, I think, or I don't know, assistant of Mr. Adalat. Or you need to ask Adalat. I have nothing to do with the exam, okay?
Well, do you at least know when the deadline is?
I don't know. I have no information. I have no idea. When is it and how long does it take? What kind of question they are going to ask and how you should actually access this exam, blah, blah. I have no idea. I'm just a teacher here, Ayan.
Okay.
Okay. So even
Thanks.
I just heard that it was today, but when is it? How you should take this exam? When you should take the exam? What is the deadline? And how many questions are there in this exam? I have no idea, Yan. Okay. I actually, you know, We just make a contract and we meet here each other, and I just teach you. That's my job here. Okay, how they organize, where to organize, and it's not my business. Okay, Ayan.
Okay.
Anything related to your Sasmo and anything related to your this kind of exams, you can contact Mr. Adalat and ask him. He is in charge of everything. Okay, good. All right. If everything is clear, guys, let's continue. Jasmine, Yasmin, are you here?
Yes, I'm here.
Okay, last time Murat and Ayan, you were absent. As you know, he 24th of February. We are just practicing these Sasmo questions and to have more idea about the types of questions. That's what we did, Ayan. And I have already, how to say, and I recorded the class and I have already uploaded in the YouTube and you can find it in the playlist. And now these days I'm trying to do everything in a day. Okay. After I finish class, I try to upload everything. And maybe after 1 or 2 hours, you can see the videos in YouTube. When you have free time, for example, you can just have a look and watch what we did. What we did last time, Ayan, is we just solved a few questions from this paper. I think we solved maybe 10 or around 10 questions. Okay, now we will continue. So these are the questions we did last time, Ayan, and we stopped here. All right, 5 questions left, and maybe now I am going to explain a few things, okay? And after that, we will actually open new paper, maybe S1 again, and you will try, okay? I will give you some time because now you have experience, you know how to solve the questions, and let's see. In this question, Jasmine, read it quickly for us and tell us how to do it. If you have any idea, if you have no idea, we will do it together.
The diagram shows a square AEFG with an inscribed circle. ABCD is a rectangle such that AB is 2 centimeters and AD is 4 centimeters. Find the radius of the circle.
Okay. Jasmine, do you remember, did we solve similar question before?
No, we didn't.
Really?
Yes, we didn't do anything like
And
this.
what do you think? How can we solve this problem? Do you have any idea?
To
I
be
mean,
honest,
we
I
have missed
don't
everybody.
have
Murat, Ayan, Rifa, Jasmine. What do you think? How do you solve this question?
I don't have an idea and I don't really like circles, so that's why I don't really know anything.
You don't like circles? How come?
I don't know, I just don't like them. They're confusing.
Mr. Abdullah,
Rectangles are the best teacher.
she's saying that she doesn't like circles. You agree with her? Do you like circles?
Excuse me, sir, I have a question.
Yes, Jasmine, what's your question?
It was Ayan, and my question is, if like there's a right angle triangle, but the hypotenuse is not straight, it's curved, can we use Pythagoras, like the theorem? Can we use it?
But I think if it's curved, it's not triangle.
I think it's a sector, no?
No, I'm
Ayan, if you are saying that curved, but by curve, what do you mean by curved? Is it a part of circle or any kind of curve? What is it? If you're talking about any kind of curve, of course we cannot.
look at the rectangle, and under the rectangle, there's like a part, it looks like a triangle, but the hypotenuse is curved.
Okay. Anyway, guys, let's do this together. All right. Here, the question is, we need to find the radius of the circle. And here, why it says that this ABCD is a rectangle. Just we are going to use that all interior angles of a rectangle are 90 degrees, right? And also opposite sides are parallel. And suppose that here is the center of the circle. And after that, if I just draw and this line segment, right? And also draw another line segment, and we know that actually these are the radius of the circle, right? It's a radius because the distance between the center, any point on the circumference, it is defined as the radius of the circle, okay? And also actually this line is parallel to AD, and this line is parallel to DC, That means that also this angle is 90 degrees. Okay. So now I will join this O and C. O and C. And since the radius of the circle is R, and also OC must be R, right? I'm not going to label them yet because I'm going to label a bit later. Now, if I draw another line parallel to, what is it? AG, okay? Now, what do we see here? Since actually here in the question it says that this one is 2, this one is 4, right? And Ayan, can you tell me what is the length of this part? If the radius of the circle is R, what is this length?
R minus 4.
R minus 2, right? Because this one is 2, so that is R minus 2, right?
Oh, yes.
And how about this length? Now this one is the whole until here, right? Until here, this part is 4. So the remaining part should be, let me just write here, R minus 4. Now here I have right angle triangle. So this one is just a radius because the distance between the center of the circle and the any point on the circumference is a circle. Now I have exactly a right angle triangle. Now I can use Pythagorean theorem, right? What is it?
Yes.
It is R minus 2 squared plus R minus 4 squared. That's equal to R squared. Or if you just expand these things, what we have here, R squared minus 4R. Of course, when you do this, you should actually, if you do this mentally, we can solve much faster, right? Automatically, you can simplify this. And here we have plus 4, and here we have R squared minus 8R plus 16. On the right-hand side, we have R squared. And this R squared, they cancel out each other. And here we have 1R squared left. Negative 4R plus negative 8R, that is negative 12R. And 4 plus 16, that's equal to 20. And here we have a 0. Now our first try is to solve this quadratic equation by factorization, right? As you see here, this 20, I can write it as negative 5 times negative 4. And how about negative 12? That's equal to, sorry, is it? No. It is 10, right? Negative 10 times negative 2. So that is negative 10 times negative 2. And this one, it's a mosquito. As you know, here, this part of the world, a lot of mosquitoes outside. But we live on the 7th floor, and all windows are covered by net. But still, I don't know how they enter the house. Sometimes 1 or 2 mosquitoes, they come to visit me, I think. Anyway, here we have negative 10 plus negative 2, right? So I can factorize as R minus 10 and R minus 2 is equal to 0. So what is R here? Is equal to 10, or R is equal to 2. Professor Murad, which one is the answer now? Can you tell me which one we should take as an answer?
I think we should take as an answer 2.
2, why?
Because like it's the radius from C, no?
Can I say why it's 10? Can I?
Yes.
Because like there we wrote that like it equals R minus 2, R minus 4. If we will do like 2 minus 4, it will be negative 2. And the length can't be negative 2.
Very good. Thank you, Ifa. Because we do not use negative number to measure the length. So the answer is 10. Dot, dot, dot. The radius of the circle is 10 centimeters. Yes, Ayan, what would you like to say?
Oh, I understood why. Okay.
I didn't understand how we got R minus 4 for the length.
R minus 4?
Yeah.
Did you say R minus 4?
Yeah.
Ayan, here, if you look at this one is radius, right? Can you see this?
Yes.
Now, if I draw another line parallel, okay, so what is this part?
4.
It is 4, right?
Yes.
Because they are equal.
Yes.
So then how about the remaining part? R minus 4.
Okay, thank you.
And also they are equal, opposite sides, right? They are equal, that's why it's R minus 4. Okay, so the answer is 10 centimeters. I hope Jasmine now, if he ask any similar question, you can answer. The idea is we need to draw some parallel lines, and after the label, actually you form a right angle triangle and label it as size and form a I mean, just using Pythagorean equation, right? And that's equations, formula, you can get the answer. This is very easy question, I think, and we are going to solve more difficult one later. In the following cryptarithm, and all the letters stand for different digits. Find the final four-digit product. Actually, here all the letters stand for different digits means that different letters stand for different digits, right? So usually in solving this cryptarithm, okay, so we have to think fast. Otherwise, really, sometimes it takes a long time. But here only we have E, H, E, E, H. This is just easy one. But sometimes if we have three, four, five letters, and it takes more time. One popular one, for example, what is it? You may try without looking at the solution. Send more money. It's just a bit difficult one. They also asked it in Sasmo a few years ago, I think. Here, different letters stand for different digits, number one. And the first letter, actually, here, the first letter is S and M and also M. Actually, by convention, they should be different from zero because we do not start writing any number with zero, right? So different letters stand for different digits, and send more money. That's why very famous cryptograph. I mean the alpha, alpha, alphametic. What is it? Alpha. Anyway, cryptography problem. So in this question, right here we have h times e is equal to 8, right? So what can be this number? Suppose that here if h is equal to 1, right? If it is 1, then e must be equal to 8. What am I teaching now?
So look, it's he and he
But M doesn't mean anything.
And if you do he and he right here, then it makes he and he. And if you do he
Okay. All right. Thank you. So, uh, I have one gamer, my son Abbas, he's 6 years old, but he's a top uh, game player. Is that right?
But I'm really good.
Yeah, all right. Okay, Abbas, you spend too much time on games. Anyway, Ayan, do you have any answer for this?
No.
Okay. Now let's continue. If it is 1, right, if h is equal to 1, then e must be 8, right? Because 1 times what number is 8? The only is 1 times 8 is 8. So if you just check this here, at the time here we have 1, 8, 8, 1, right? Now from here, if you multiply 8 by 18, it will be 3-digit number. But here we see, what is it? 2-digit number. And that's why h cannot be equal to 1. So immediately, actually, I will move to the next digit. Since it cannot be equal to 1, how about if h is equal to 2? If h is equal to 2, right, this a must be equal to 4. Or it should be 9, right? We have two possible answers here. Then if it is 2, at the time here we have 24, 42. If you multiply this, 2 times 4, 24, it is 48. 4 times 24, it is 96. So the answer is 80, it is 1008, right? Now it works, that's the answer. If you check other numbers, actually it doesn't work, right? Because for example, it is 9, 29, 92. 9 times 29 is more than 2-digit number. That's why it's also not the answer. Okay, so here the answer is 1008. Okay, Murat, Ayan, Jasmine, Rifa. That's easy question, I think. We will move, but send more money when you have free time. You may try. Just actually, why you should try? Just to do some mental exercise. All right, it really actually sharpens your thinking skill. So, Ayan, do you remember this question? Did we solve this kind of question before? First, Ayan, can you read the question? And after that, let's discuss together, right? Because anyway, Ayan, read it.
Okay. A farmer wants to plant 10 trees in 5 rows, such that there are exactly 4 trees in each row. Draw a diagram to show how the trees should be planted.
Any answer, Murad, Ayan, Jasmine, Rifa? Let me give you 1.5 minutes. Think, okay? And after that, let's discuss it together. Jasmine, what do you think? Did you understand the
Mister,
question? Yes, Ayan.
No.
this problem makes no sense. If there's 4 trees in each row and there's 5 rows, there'll be 20 trees, not 10 trees.
Yes, it's confusing.
Jasmine, so one question is confusing. You don't want to try.
Teacher, my copybook, it's full of circles again. Like small circles for the trees this time. It's always full of circles.
Mr. Murad, actually, it's a type of question that you like. What do you think about this question? Murad, are you still there or?
So right now, I don't think anything because I am at the street and I'm trying to get off the sabaka of the dog. Yes.
What are you doing?
Right
You're
now,
outside doing what?
yes. I came to a hotel because I'm not at home, and right now I'm trying to get off the dog. Okay, I'll answer in 5 minutes when I go into my room. Okay, just a
Okay, no
second.
problem. No problem. Okay. But here, actually, Ayan, Jasmine, Rifa, but this kind of questions, some questions, what is it? We call this thought-provoking questions, right? Yeah, when you look at this, you see that oh, it's not possible, but actually it is possible. Okay, but here the key point here is a farmer wants to plant 10 trees in 5 rows. It's actually we mean that by rows like 5 lines, straight lines. Okay, such that there are exactly 4 trees in each row or in each line. Let's say
Am I the only one who doesn't hear
diagram
me?
to show how the trees should be planted. Rifa, what did you say?
It's not me, it was Murad, and Murad said that he don't hear anything.
Okay. How about if I actually plan like this? I am look here. I actually want and one and one and one and one. How many lines? 5, right? Here we have 1 3, 1 3, 1 3, 1 3. I can draw more beautifully actually. It's just a star shape. 1 3, 1 3, 1 3, 1 3. Again, in this line we have 4, right? If you just look at every line contains 4 trees, right?
Mr. Kazam,
Yes.
these problems, like when you solve them, we understand it. But if we were to encounter them in a test, how can we come up with these strange explanations?
Exactly.
Very good, very good. Aya, now I will answer your question. Okay.
Teacher, I would
Uh,
say I'm the least creative person you would ever meet.
no, Jasmine, just I want to tell you something, all right? So suppose that here, okay, this is a kind of buckets. Okay, what is this? This is our knowledge or experience bucket, whatever you call this. All right. And suppose that actually it is empty, right? But now learning, studying these things, you're just actually collecting things, right? You're making this some to some extent. Maybe still some part is empty. Okay. So now if you just fill it to some height, right? And just filling to the how to call this? We call this brim, right? Brim of the pail. Anyway, to fill this one will be quite easy, right? So now you are saying that okay, Mr. Qasim, now if you don't solve this, we have no idea how can we do this. by watching this ion, actually maybe consciously or unconsciously, maybe you are not aware of this. At the same time, you are gaining experience, all right? You're collecting ideas, all right? Now, before this, when you have a problem, you need to solve this and check your bucket, okay? Do you have any idea, any method here? It is empty, right? But now starting, even at least just watching this, you have some ideas. Okay, now we have a problem. Check this idea, doesn't work. Check another idea. At least you have some collection of ideas. Now, if you just think the opposite, Jasmine, Ayan, suppose that you don't have this kind of class and you only satisfy with your school math and you have, let's say, some homework, you just do this and years pass, right? And what do you gain? Okay, just compare these two situations. And taking this kind of class and solving different kind of questions, actually, you may think that, okay, I cannot solve this question. How can I improve? You are improving now. You are having some idea. Okay, so next time, if you have some questions similar to this, at least you know you have some idea to try this. You have some tools, right? How to try this one. And step by step, you are developing your thinking skill. You are actually expanding your idea bag, let's say. And if you just continue learning like this, Ayan, let's after 6 months, you just compare. 6 months ago, where were you? But now, where are you? And to see this one, just compare yourself with other classmates. And you will see the big difference, Ayan. Because coming here, sitting and watching and discussing, reading the problem, you are learning a lot of things. Okay, because here, Ayan, how many months actually we are having this class? 2 months, maybe two, I think, right? And it's a not big deal actually. You'll see that after maybe 1 year, if you have class like this, you will make a lot of problem. It's just we are sharpening your knife now. Okay, after a certain point, you will see that. Look at the question. At least you have some self-confidence. You know how to give it a try. You know, because in your hands there are some tools. You know some methods how to try this. I don't know how much I explain. That is what I think about education, about learning, about how to say participating in more classes, participating in discussions. Okay. And that's a good thing. Anyway, let's continue then. Let's move to the next question. Find the last three digits of 25 to the power of 25. Okay. And also, this question is what is it? Just we need to do some calculation 25 to the power of 1. What is the last digit? Two digits, only 25. And how about 25 squared? It is 625. And how about 25 cubed? It is 625. What is it? Just a minute.
It is 15,625.
What is it?
15,625.
Okay. Actually, we know how to multiply 625 by 25. And after that, how do I multiply this six? For example, 25 cubed, right? And you don't have to calculate. I mean, with a long calculation, or with if you're not allowed to use a calculator, how do you do that? I would just calculate like this: 25 cubed. I can write it as 25 times 25 squared, right? And which is equal to 25, and this one is 625, right? So now, uh, okay, 625, 100, 300s.
Teacher, are we allowed to use calculators during the exam?
No, you're not allowed to use a calculator in the exam. Okay. So anyway, this 25 cubed, 25 times 625. And because of this one, what is it? 5 times 625, right? Again, Anyway, so what we have to do here is in this count of numbers, okay, just write maybe 3 or 4, then you will see the pattern. If you just multiply one more, for example, to the power of 4, and you will see that the last 3 digits will be 625. Okay. How do, if you ask me, how do I know that? Because 5 to the power of 4, it is 625, and this 20 plus 5 to the power of 4. And because this 5 to the power of 4 is 625, anyway, 25 to the powers of something, okay, always the last digit is 625. Because if you just write like 4 numbers, 625, 625, 625, now we can actually see that, that the last 3 digits of this number must be 625. Okay. Actually, I'm just trying to explain some different way, but now idea doesn't come. So again, maybe we may retry this question later if I had different idea. But usually in this kind of question, like for this question particularly, just write like 3, 4 steps. What do you see? Is there any pattern or not? But here, as you see here, if you just write 4, for example, until uh, 25 to the power of 4, the last 3 digits are 625. Okay, if you just continue, it takes a long time. But in Sasmo, they don't ask a question that actually requires a lot of calculation. Anyway, another question, find the remainder when 3 to the power of 2014 is divided by 5. Okay. We did similar question. All right, we did one more time using that method. If you remember, what method did we use to solve this kind of question? And we know that a plus b, a plus b to the power of n, right? We can always write it as a times some number plus b to the power of n. Okay. So I will just use again this idea. This, we know that 3 to the power of 1. If you divide by 5, the remainder is, what is it? 3. 3 squared, if you divide by 5, remainder is 4, right? Yes, Ayan.
I don't really understand that equation because a plus b to the power of n, won't it just be a to the power of n plus b to the power of n? How will it be a times n?
Okay. Ayan, Ayan, do you know what is this? What does this S stand for?
It's like x.
Not X. Actually, it stands for any some natural number.
Yeah.
Okay. And once again, actually, maybe just revision. Okay, let me just write here. How do you call this? It's Newton's triangle, I think, right? If you remember this one, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And I can continue this. Ayan, did you ever see this triangle?
No.
If you ever seen this, now actually you see this. Okay, that's actually a popular one. And what are these numbers? Actually, how am I constructing these ones? I just start with 1, okay, and after that just write 1, 1, okay, and after that just add these numbers. Here we have 1, 1 plus 1, it is 2, and here we have 1, okay. Now here we have 1, 1 plus 2, it is 3, 2 plus 1, it is 3, again we have 1. And after the continue here, 1, 1 plus 3, it is 4, and 3 plus 3, it is 6, 3 plus 1, it is 4, and here we have 1. Okay. So what are these actually? These are the coefficients of this binomial expression, this a plus b to the power of n. For example, let's say here we have a plus b to the power of 0, right? What is it? Actually, just here we have only just 1, right? That's the first one. Actually not the first one. If we have a plus b to the power of 1, it's just equal to a plus 1. As you see here, the coefficients are, that means that we have two terms, the coefficients are 1 and 1, right? And how about if we have a plus b squared, right, is equal to a squared plus 2ab plus b squared. What are the coefficients? As you see here, the first coefficient is 1, the second coefficient is 2, and third coefficient is 1. And here we have three terms. And let me just show you one more time. How about if we have a plus 3 cubed, right? So that is a cubed plus the second coefficient is 3. So here we have 3a squared b. And next coefficient is 3 here. We have 3ab squared. And the last one is just 1. Here we have b cubed. All right. So now, Ayan, here, I'm just actually telling you very simple thing. All right. So that's actually b, not 3. If you look at the last part, just look at this one. Okay. And just single out the last term here. Okay, just keep this here. And the remaining terms, right? Is a common factor?
Yes.
So if it is a common factor, right? Can I just write it as this a plus b cubed, right? Can I just write it as a times some natural number, and here we have b to the power of n? Because I'm not interested in this number. What I know about here, it's a natural number. This is what I know. It may be very big number. I'm not interested in this, okay? And what I know that actually that remaining part, it is divisible by a because a is a common factor as you see, okay? So, and again, the question is, yes, Mr. Carson, why actually you want to write in this way? Because if you divide any number, let me just show you one more time. If you divide 17, right? For example, let's say if you divide this by 3, okay, the quotient is 5, right? And the remainder is 2, right? So now how can I write this 17 different way? So I can write 17 as 3 times 5 plus 2. Okay. So what numbers are interesting for me here, Ian? Here, I am interested in two numbers. Actually, I'm interested in this, okay? I'm interested in this, okay? For me, this 5, it's not interesting. I'm not interested in this. Here, the question is, from this expression, I can see that if you divide 17 by 3, the remainder will be 2. Even I'm not mentioning this 5. And that's why, in general, if we have a plus b to the power of n, I can just write it as a times n. N is some quotient, all right? It's whatever it is, but I'm sure that it's a natural number. That from here, I can see that if you divide this a plus b cubed by a, the remainder will be b cubed. This is how we should read this.
Okay. It's still confusing, but I somewhat understand it.
If it is confusing, then you are learning something, Ayan. If everything is clear, what do you learn? Nothing.
If everything is clear, then you get to understand it.
If everything is clear, what do you understand? What do you learn?
The problem.
If everything is clear, it means that you understood it. Like nothing is blurry. Everything is clear.
Okay, here 5 plus 9.
Yes.
Rifa, is it 14? Do you understand this?
Like yes.
Is it clear?
Why not?
Do you learn anything from this?
No, I don't learn something from this, but I do understand it.
Okay, so actually what I'm trying to say here is if something is confusing, okay, that means that it is pushing you to think a little bit differently. That means that it is pushing you to learn something new, right?
Not really.
Why not really? Why?
Because when something is confusing, you just don't understand it and then you forget about it a day later. That's what
I don't know.
happened.
Aya, maybe, Ayan, Jasmine, Rifa, maybe actually our nature, our character may be different, but usually If I cannot do something, if I don't understand, I want to try that kind of thing, not something that I understand. And maybe it's my nature, if I don't understand something, I really want to learn. If something is clear, when I read, I understand, it's not interesting for me. Okay, that is, I don't know, this is what I feel, because of course it's something interesting and it's confusing, and immediately I think, okay, why actually is confusing for me? How come I don't understand? Okay, I just actually I cannot be relaxed. I really want to understand why is this so. Why don't I understand? And sometimes it takes time. For example, especially maybe you're studying at school now, but in the future, let's say when you're doing some job, okay, you need to do some kind of task. Okay, just think. For example, what is it? Let's say Jasmine is doing some flower business, for example. Okay, in the market, a lot of people are selling flowers, right? And if you just open one shop and bring flowers and you're just doing something that everybody is doing, right? You cannot make much money, right? You should do something that people actually it attracts people's attention. And they should say, wow, Jasmine, what are you doing here? Right? So actually this kind of business brings money, right? If you just do everything the same with everybody and you cannot make something new, I mean, it will not be attractive. Anyway, I am what I suggest you is okay, if you don't understand, uh, just watch, okay, listen, and after the class, write it down once again. Okay, when you write down, I'm sure that you understand something, but sometimes some problems it may take time to understand, and that's also the reality. Maybe what I'm writing here, you understand everything, but what is the logic behind this? It may take time. Jasmine, let me tell you one joke. Is it okay?
Yes, you can
It
say
is
it.
not a joke, but just experience, all right? Sometimes today is Monday, for example, or today is Friday, right? Friday. And sometimes to the class, I tell a joke, okay? Friday, all right. And I have class to this group next Wednesday, for example, okay? And sometimes I tell a joke on Friday in my class, and I see some students in my class laughing on Wednesday, okay? And I ask on Wednesday, all right, okay, Mr., for example, Michael, why are you laughing? And he says that, oh, Mr. Custom, last Friday you told us a joke. And so I told you a joke last Friday. Why are you laughing now? And he tells me, I just understood your joke now. So that's also reality. Sometimes you tell something, even a joke, people understand maybe after 1 week or 2 weeks, maybe even after a month. All right. They say, Mr. Carson, now I understood your joke. So sometimes you should give it time. Okay. And this is a joke, but the reality I am. Sometimes, okay, I explain, maybe I don't know the easier way, but that's the way how we teach some stuff. Okay. If you don't understand, try, write on a piece of paper and just keep thinking. Also just keeping thinking, that's also something good. It's a part of education, part of learning. Anyway, guys, let's move back to this question. I think we talk a lot. Simply, what you have to know here, Ayan, I'm just writing two things. Suppose that we are given A and B and this some number, okay? These are some natural numbers. All right. I'm saying that here, if you are given this A plus B to the power of n, I can always write it as A times some capital N plus B to the power n, which means that by this expression, I mean that if you divide this number, it's some number, right? By A, the remainder will be B to the power of N, okay? And to understand this immediately, Ayan, you just give one example to yourself. Okay, what is it? For example, let's say 6 squared, for example, right? And 6 squared, I can write it as 5 plus 1 squared, right? And if you expand this, here I have 5 squared plus 2 times 5 times 1 plus 1 squared equals, now here we have 5 is a common factor. Take this out. So what is that? Here we have 5 plus 5 is out. Here we have 2 left, right? Here I have 1 squared. And now I can just write it as 5 times 5 plus 2 is 7. And plus here we have 1 squared. Let me just label this by some number n. As you see, it's a natural number. So then I can write it as 5 times some number n plus 1 squared. Now from here, what do I understand? That means that if you divide 6 squared, okay, by 5, okay, the remainder will be 1 squared. And what is 1 squared? It's just equal to 1. Is it true? Now if you check this, what is 6 squared? 6 squared is 36. So I have 36. I can write it as 5 times some natural number plus 1. Actually, what's our n here? It is 7. But 7 actually it is not interesting for me. Okay, that's why I'm just using m. It can be 7, 8, 9, whatever it is, doesn't matter. What I know here is it is just a multiple of 5. So now using this idea, I'm going to answer this question. Okay, so now I can write 3 to the power of 1 as 3 times 0 plus 5. Divide by 5, right? Not like that. 5 times 0, 3. What does it mean? That means that if you divide 3 by 5, remainder will be 3. And how about 3 squared, for example? It is 9, right? I can write it as 5 times 1 plus 4. That means that if you divide 3 squared by 5, remainder is 4. And how about 3 cubed? It is 27. I can write it as 5 times 5 plus 2. Remainder is 2. And how about 3 to the power of 4? We know that 3 to the power of 4 is 81. 81, I can write it as 5 times 16 plus 1. Okay. Good. Actually, this is what I'm looking for. Okay. I was looking for when actually the remainder is 1. So what do I understand from here? That means that now I'm just going to do very simple math here. Okay, instead of this 4, okay, if I write 3 to the power of 4n, on the right hand side, what we have here? 5 times 16 plus 1 to the power of n, right? Because the whole thing is 3 to the power of 4. And here we have n. So now using that formula, I can just write this 5 times 16, not 16, actually, because raised to the power of m, I have some natural number n, and here we have 1 to the power of n. And 1 to the power of n is just equal to 1, so that's equal to 5n plus 1. Okay, so what does it mean? It means that the powers of 81, right? This one is 81. If you just raise this 81 to the power of any number and divide by 5, remainder is always 1. Now, if you get back to this question here we have 3 to the power of 2014, right? So now 2014 is not divisible by 4, but I can write it as 2012 plus 2. Now 2012 is divisible by 4. That is 4 times 503 plus 2. Okay, so now here we have 3 to the power of 2014, and I can write it as 2014 as 4 times 503 plus 2. And we know that I can just separate them, right? The powers. I can write it as 3 to the power of 4 times 503 times, here we have 3 squared, right? So which means that this 3 to the power of 4, right? I have just written here. So that thing is equal to 3 times 16, not 3 to the power of 4, right? That is 85 times 16 plus 1. I'm talking about this 3 to the power of 4. And in the power, we have 503. And outside, still I have 3 squared. Now using this one, what is it? I can just write it as 5 times n plus 1. And here we have still 3 squared, that's equal to 9, which is equal to, if you open the brackets, 5 times n times 9. Here I have 9n plus 9 times 1, 9, right? And that means that if you divide this number by 5, the remainder is 9. But 9 is still greater than 5, right? Again, I can just write it, again, it's just simple math. I can just write it as 5 times 9n plus 1 plus 4, right? Because just 9, I wrote it as 5 plus 4 and take this 5 out. So 9n plus 1. It is something, again, I'm not interested in this. That means that if you divide by 5, what we have here, less than 5, the remainder is 4. So here the answer is, the remainder is 4. Okay, Aya and Jasmine, actually, I just tried to explain in details how we should approach the problem, but I'm sure if you just practice a few questions related to this, it is not so difficult or challenging. Okay, maybe the first time you see this kind of method, that's why it may be a little bit confusing. But if you just try like a few questions, okay, you will see that it's quite easy. Now we can just try, for example, 3 to the power 2014, find the remainder when it is divided by 2, for example, when divided by 3, for example, when divided by 4 or 5 or 6 or 7. Try similar questions, 3, 4, and you will have more idea. And okay, so that is,
Никто не плачет.
huh?
Nothing, nothing.
Okay. The last question, find the largest number of composite numbers less than 2014 that are relatively prime to one another. An example, the highest common factor of any two of them is 1. Okay. Again, maybe, I don't know, have you, Ayan, have you ever seen this word before, relatively prime?
No, I haven't.
You know what does prime mean, right?
Yes.
Okay, relatively prime means two numbers are relatively prime if their only common factor is 1. Okay, for example, 2 and 3, these are relatively prime. 3 and 5, relatively prime. And 4 and 5, relatively prime. Why? Because only the common factor is 1. Okay, so we call them relatively prime numbers. So here it says that find the largest number of composite numbers. What is a composite number? It's again a natural number which has more than two factors, right? If it has exactly two factors, two different factors, we call them prime numbers. If it has more than two factors, we call them composite numbers, right? So now, if you actually factorize this 2014, right? 14, that's equal to 2 times 107, and that is 2 times 107 is divisible by 19, divisible by 19, that's equal to times 19 times 53. If you remember, also actually we did this before. I mean, have seen this, we have factorized this number before. And how about 2013? 2013, it is divisible by 3, right? Because the sum of the digits divisible by 3. I can write it as 3 times 6, 21, 7. It is 1. Now again, 7, 14, it's not divisible by 3. And 6, 7, 1. Is it a prime number? 6, 7, 1. 6, 7, 1. Is it divisible by 7? 41? No. 11? Yes. So we can just write it as 3 times 11 times 61, right? As you see here, these two numbers, they don't have any common factor except 1, right? There's 2 1953 prime numbers, 3 11 61 prime numbers. So actually this 2013 and 2014, these two numbers are relatively prime numbers. So then the highest, biggest number that is uh, less than 2014, that is relatively prime to 2014, is 2013. Okay, Murat, Ayan, Jasmine, Refa, thanks for your attention, time, patience. And I have already shared one
Okay.
paper. Let me just see in WhatsApp, okay?
Thank you,
If you have
mister.
already finished, I may give you another paper until next class, okay? So I wish you good luck in your exam. If possible, make a screenshot and keep the questions And if there are some interesting questions, we can discuss in our next class. Okay. Have a nice weekend.
Yes, sir. But anyway, like this exam is kind of a test. It's not like real exam, so I
Yeah,
think it's nothing.
it's not about actual real exam or not, Murad. It's about, actually these questions are prepared by some good mathematicians, and for each question actually they are paid, and they spend a lot of time preparing. A good question is not easy. Okay, I'm saying that if you like a question and a nice question, okay, just like thought-provoking question or challenge question, bring it here. Also, I want to see, okay, discuss together with you. Okay, if you want. If you don't
Okay,
want, it's okay.
Goodbye,
okay,
have
mister.
a nice
Bye
Okay,
weekend.
bye.
teacher,
Have a
thanks.
nice weekend.
Bye,
Bye.
mister.
Bye. Have a nice
Bye.
weekend.
Thank you. Bye bye.